Thank you, guys.
Welcome, everyone. I'm Ryan Nugent here at Cal Poly. I'd like to welcome all of you to the Digital Engineering Live Q&A panel that we have right now. I'd like to thank all of our panelists for joining us and for providing those pre-recorded presentations. They were all extremely interesting. Before we get started, we'd like to highlight one of our sponsors for the event. Our sponsors are what allow us to make this event free for all of you. So for this session, we would like to highlight NanoAvionics. NanoAvionics is an exhibitor, and they had a great side meeting this morning. We'd like to show a short video from them. So if we could do that now, that'd be great. As we're getting that figured out, waiting for it to start. Also, NanoAvionics, they are launching a 6U that they built for a customer later this evening or tomorrow morning, depending on what time zone you're in. So definitely connect with them at their exhibit and their social media, which will drop in the chat, and you'll be able to follow that live, either, like I said, tonight or this tomorrow morning, depending on your time zone. So it looks like we're ready to play the video.
Small satellites once relied upon bespoke designs. One-off purchases and qualifications increased costs and lead times. NanoAvionics applied modern industrial principles to nano-satellite design.
We decided to commercialize, to industrialize, and to standardize our products in order to make them cheaper, in order to make them more reliable, in order to make them more repeatable.
NanoAvionics M6P is the first pre-configured nanosatellite bus. Standardization makes supply chains predictable and efficient and lets NanoAvionics to pre-integrate and pre-qualify the M6P's subsystems. The M6P uses a redundant UHF transceiver, an S-band transceiver, as well as an intersatellite link to conduct real-time communications with ground stations. The M6P's attitude determination and control system uses sun, inertial, and magnetic sensors, as well as GPS and star trackers to determine the M6P's attitude with high precision. Then reaction wheels and magnetorquers adjust the M6P's attitude, letting the satellite perform maneuvers like tracking the sun or targeting positions on Earth.
Again, thank you to NanoAvionics for being a gold sponsor at our event this year. Like I said, you can find in the chat their virtual exhibit. Please connect with them this afternoon or tomorrow, and their social media. With that, I will introduce our moderator for this panel. That is Dr. John Bellardo. Dr. John Bellardo is one of the professors here in the CubeSat lab at Cal Poly. Dr. Bellardo received his PhD from the University of California, San Diego, where he studied computer science. He's been a professor here at Cal Poly since 2005. Dr. Bellardo has also worked in the Cal Poly CubeSat lab for the past 12 years, which has been involved in 10 of our CubeSat missions. With that, Dr. Bellardo, the floor is yours.
Thank you very much, Ryan. I'd like to also extend a welcome to the panelists. Thank you for taking the time out of your day to join the Q&A session. So I'm going to start with Robbie Robertson. Let me introduce him. Robbie is the CEO and co-founder of Sedaro Technologies, a provider of cloud-based satellite engineering tools. Robbie was previously the product development manager at IBOS, a space avionics provider, and has held research positions developing physics-based models of spacecraft dynamics at Los Alamos National Laboratory, Air Force Research Laboratory, and the German Center for Quantum Engineering and Space-Time Research. Robbie, can you please take a couple minutes and provide an overview of your presentation?
Sure. Thanks, John. Thanks for the intro. So in our presentation, CubeSat Digital Engineering with Sedaro Satellite and OpenMBEE, we talk about some of the advantages of digital engineering for CubeSat missions, and kind of the potential that digital engineering workflows offer for making these development efforts much more efficient and collaborative. And as part of that, we have a demonstration, a pretty simple demonstration of how to use our products at our satellite in concert with the open source platform for model-based engineering called OpenMBEE to refine some design parameters for a CubeSat mission. So this is a capability that we're integrating into our tool, out of our appreciation for the value that these kind of collaborative workflows could have for small sat teams. So we're hoping to kind of potentially have Sedaro Satellite be a catalyst for a lot of these small sat teams to adopt OpenMBE and other systems for improving the efficiency of their engineering efforts.
Thanks. I had a couple questions when I was watching your presentation. The first, I've talked to people with various backgrounds. Some have drunk the Kool-Aid and are gung-ho in digital engineering, and some might be a little more apprehensive, and they want to see the benefit it provides them. So I guess my question is, what's available right now from Sedaro that they could go and maybe dip their toe in the water and decide if this is a good fit and if there's value in the product and the platform to them?
Sure. So we finished the platform. We finished the first module in this modular digital engineering platform that's called Mission Designer, where they can design their orbit, pointing, and ConOps, and simulate that throughout the whole mission lifetime if they'd like, and start doing some design work and trades. It's not released yet. We expect to do that in the next few months once we finish some export control classification stuff. And once that's done, we're going to be offering free trials, so people can go online, sign up like any kind of software as a service web-based tool, and start trying it out and using it. So that's one way to dip your toe in the water. That's very easy with Sedaro Satellite. And as we grow the platform and add modules for power system design, attitude control system design, they'll be able to trial those as well and kind of reap the benefits of that integrated modeling and simulation capability. Sedaro Satellite itself is kind of meant to be a out-the-box, for small satellite developers, model-based digital engineering platform. So they don't have to do the legwork of creating their own system and creating their own kind of data flows and interfaces between their different tools. It's pre-built for that purpose. But we certainly understand the apprehension of certain folks towards digital engineering because there's so much upfront work required to set up those systems once you start trying to connect your different traditional tools together. And so I think as a starting point, OpenMBE is a great option, which is why we focused on that and are interfacing with that platform. It's free, it's open source, there's a good community behind it. It came out of JPL. And there's instructions online about how to set up your repository for your engineering data, and then start connecting things into it. So among what's out there, I think that's a good starting point. Looking at the openmbe.org website, and then you can try and set it up yourself.
Cool, thanks. Another thing that came to me when I was watching your presentation is I saw a lot of parallels with sort of the recent push for continuous integration on the software side of things, right? Where they're trying to, you make a change, it's a new version, it automatically starts testing the software and gives you, reports within, hopefully minutes, depending on how long the tests take, right? So there's definitely a lot of parallels between that. So my question is there a similar system in place currently, or is that envisioned to be able to tie all these components together and actually you make a change in your spacecraft configuration and actually runs through all your simulations and automatically creates those reports and updates everything for you?
Yeah, so with Sedaro Satellite, if you make a change in any module, it automatically updates, all of the other modules. So when we add, for example, the energy balance module where you're modeling the power system, modeling your power system involves, modeling the power generation from your solar arrays, and that's obviously dependent on the position of the satellite. But we don't exclusively we don't model that in Energy Balance. We model it in Mission Designer. And so if they made a change in Mission Designer to their ConOps, which would change the operational modes that they're in, so it would change their power, their power modeling, and it also would change, you could change your orbit. If you changed any of those things, it would automatically carry through to all the other modules, and any modules that have dependencies on those changes would get automatically resimulated along with the orbit and pointing simulation that lives in Mission Designer. So it would tell you that those are being updated and do it automatically. So that's kind of the Sedaro Satellite part. In OpenMBE, they're taking an approach that's similar to, I think, what you were alluding to with software development, where you're always creating all these automated tests that run before you release anything, and you have really good version control, and people are able to create branches of the project, work in those branches, test them, and then push them back to a master branch. That structure can be implemented in OpenMBE. So you can be doing work in Sedaro Satellite and in another tool that's plugged into their system, maybe some Python scripts or something, your own in-house tools, and you can both push data to a central repository and have version control over all those transactions and good tracking and traceability.
All right, thank you. I think we'll move on to the next presentation now. So we're going to switch over to DeltaV Robotics, and we have DeltaV represented by two folks here. First is Naushad Rahman. Naushad is the founder of DeltaV Robotics with the aim to make space more accessible. He is a NUS Singapore alumni. He has passion and experience for engineering. He has developed a high-performance computer application for space and medical industry. Also from DeltaV, we have Neha. Neha is the co-founder of DeltaV Robotics. She has done her master's in engineering from NUS Singapore, a data scientist by profession who has an ample amount of hands-on technical and business experience for engineering and medical industry. Could you please provide a brief overview of your presentation?
Okay. Hi, thank you for our introduction. Yeah, so our presentation is a SatPass tool from your system engineering to digital prototyping to a digital twin. So our software named SatPass, which is a full form of satellite path analysis, test, and simulation. User can use from a day one to input their requirement to make a digital prototyping, and which helps them, because the digital twin is a journey which starts from your system engineering, digital prototyping to a digital twin, and we are assisting our user to make it faster and to bring a digital twin as an enterprise software.
Thank you. So I'll open with a similar question for you today. I open with Robbie. What do you have available today if people, again, we're trying to test out the different solutions available, see if it works for their project. What's available from you?
Yes. So what we have done, the first two portion, that is the system engineering management, it is ready. And from the digital prototyping, orbit propagation and attitude and control determination systems, they both are ready. So the user can try and test it. And the analysis both in their 3D, 2D visualizations and the mission analysis with output. So it's a cloud-based application. The user can simply go in, log in for a free trial, or just contact us and we can provide them the software.
Okay, thank you. One of the things that jumped out to me when I was watching your presentation, I didn't hear a whole lot about mission planning. So I'm wondering what mission planning support exists in the tool right now and what you may have planned for the future.
So currently we are working with our ISRO team. So they are ex-ISRO scientists. They are helping us to develop how can a user can determine what kind of orbit they want to do it exclusively. Currently we are focusing on Earth observation. So they'll give a different parameters for the payload, what do you call that, camera, your aperture value, your height, a different range of height, and we can find out the optimum value of that orbit, so that user can use that value in their system engineering so that input that system into your system requirement, and then they can flow directly to the digital prototyping for the selection of different components, like their sensors, their OBC, their solar panels. So we can even simulate that portions.
Okay, thank you. The other thing another thing that jumped out to me, you definitely mentioned you have version control for all the requirements portion of SatPass, but I didn't hear mention in the presentation of version control for the other portions. So I was just curious if that also exists for the other portions.
Yes, actually there is version control and history tracking, and everything is incorporated there. We did not mention in the presentation, firstly, because of the time limit, that we need to be precise and concise. So yes, if the users want to control anything, like if they want to go to their previous mission, or even if they have simulated anything with any kind of parameters, everything is stored. And if they want to go back, they can see. Also, they can generate the auto reports, like as you mentioned, like because it's a software, so they can generate the verification report, error report, everything is automated, and the versioning can be done on that. So
Sounds
that's
great.
also exited, yes.
Thank you very much. Next, we're going to move on to hear from Red Boumghar. Excuse me. So right after a data science research fellowship for AI-based spacecraft operations analysis at the European Space Operations Center, Red joined the Libre Space Foundation as a core contributor to the Polaris project. He now works with an international team of roboticists, systems engineers, cybersecurity experts, and passionate aerospace students in one of the most advanced tools for deep learning based on telemetry and situation analysis, which is totally open source. So Red, can you please give us a short overview of your presentation?
Yeah, sure. If you can hear me well, that's fine. Can you?
Just fine. Yes, perfect.
Perfect. Okay, great. So yeah, so in the presentation, I go through what's Polaris. So what do we have in the tool? So we are using machine learning, but what kind of data we use? So we have first in the pipeline, we have how we fetch data, and we rely a lot on the SatNOX project from the Libre Space Foundation, which gathers a lot of different missions, CubeSat missions. And then I show the core, the two main things we have in the core. So we have two main tools, one which analyze the dependencies between your telemetry, which is important when you want to analyze what's the source of an anomaly in your spacecraft, because you have so many parameters. It's kind of hard to understand everything all the time. And then we have another tool which is more toward anomaly identification and recognition. So it's about segmenting the different behavior of your spacecraft in a kind of a holistic view, and also taking into account environmental impact like space weather. And so I'm showing all this, showing the interface we have. We have kind of a nice 3D graph visualization, and this is open source, so we're doing everything publicly, and that's pretty cool to do that actually.
Sounds good. One of the things that I've always liked about automated anomaly detection is that you have the potential to actually run it on the spacecraft, right? One of the challenges that we've had in some of our missions is you never really get all your engineering telemetry down, because you very quickly want to switch over and get your science data, right? So the engineering data you get is either incomplete, or it's not at a frequency that you'd really like to detect anomalies, right? So maybe you're getting data points every 5, 10, 15 minutes as opposed to data points every second.
That's
right.
A
So
good point.
Yeah. So one of the things that I've always liked about these type of programs is the ability to actually run them on the spacecraft. So I guess my question is the project at a point that you might actually be able to host the detection portion on board a spacecraft and produce automated summary reports using the higher fidelity data that's available on board?
So we're at that point where we're actually trying to test what we have. So we're reaching out to spacecraft operators. So that's why I'm super glad to be here also. So we can reach out to you guys. We want to test that with them first on ground. So but definitely you have like some telemetry parameters that are available at frequencies that you only have on the spacecraft, and there you have observability of different behavior that only available on board. This whole project actually started, the core people in the project started by analyzing how you can run machine learning on small computers and microcontrollers eventually. So then we went to that was 2018. So we went to ground. So you can imagine the decision, ground first. So with the big computers, but then learning from that, the reporting is also like super important. How you do it, because you said it, you don't want spend too much time on your telemetry. You want to focus on your science data. So you need somebody or something to do it for you.
Yeah. On a related note, what if somebody, again, thinking into the future, or somebody wanted to put on their spacecraft, what technology stack does their spacecraft need to support in order to run the software?
I would more say like what kind of hardware you need.
Okay.
Yeah, but in terms of technology stack, to answer you, I think we have things like TinyML, so kind of small versions of big libraries like TensorFlow that could fit on small hardware. So we're looking at into this actually. But then we're using Python, so the whole stack is in Python. So some dependencies might need pre-compile things, but we're using Python the whole way. Yeah.
Okay, sounds good. So another thing that interests me in your presentation is you had a lot of you used the LightSail-2 telemetry as an example a few different times, right? Because obviously that the Planetary Society makes that openly available, so it's very convenient. Now by this point, there's a lot of data. So my question is, have you done enough testing with that data set to have identified some anomalies? And specifically, I know LightSail has published some information about anomalies that they identified, right? Have you done any cross-checking with that, and have you found anything new, or how's that work?
Yeah, that's where we wanted to go. So we didn't have like direct interaction with them, but we have another mission called Bobcat 1. One of the guys is actually a contributor to the project, so we kind of discussed with him. But that's definitely the next point we want to reach this summer. So we have the Google Summer of Code. We want to output reports. We've seen that we miss those reports where we can actually compare to a list of anomalies that have been identified by the team. And so far, you have to be a developer to understand what's happening. That's the thing.
Yes, you definitely need detailed knowledge of the spacecraft to interpret some of those telemetry points, right? Which is also the benefit of.
Yeah, we've seen some things. Yeah, so we're in the graph. We can see things that are the battery linked, battery temperature linked to the number of images you're taking. In the beginning, like, what's the relation? But I think space travel operation engineer understand that if this is electronic working, that it's pulling current from the battery, then it's heating it up. So that's what we kind of observe at some point. That's the kind of relations we have in the graph.
Yeah. And that challenge, not really understanding the spacecraft, is actually one that's addressed by a couple of the other presentations when you're creating these engineering models in the software and virtual models of the spacecraft, right? So that's all related. All right, thank you. Before we get to the last presenter, I just wanted to remind everybody that if you have a question, please feel free to post the question in the Q&A, so we can get to that here in a couple minutes. And if there's a question you like, there's a little thumbs up. You can upvote the questions, and then we can, presumably answer or ask the most popular questions. All right, our final panelist today is, excuse me, is Vikram Udyawer. Sorry about that. Vikram is founder and research lead at Clayming Space, a podcast centered around social sciences in the space industry, featuring diverse perspectives with a focus on digital economies in space ecosystems. He is an alumni of Rocket Lab, DLR, SGAC, and Sabre Astronautics with qualifications in engineering and commerce. Vikram, can you please provide a about 2-minute overview of your presentation?
Yeah, sure. So we kind of introduced a problem that regarding registration delays and how we can potentially solve it using a voluntary incentivized transparency approach by tokenizing spacecraft IDs as part of the United Nations Registration Convention. One thing's what we do is we introduce some of the primitives of crypto economic systems, which is what we use. And then we go through a markets mechanism and design methodology where we sort of model the exchange with a use case and develop an architecture, mention some initial value captures for a fractional token for that use case, and simulate a bonding curve associated with that crypto economic system. And then finally, we mentioned sort of the future directions and implications of creating like a digital public economic infrastructure to create a more like sustainable space environment and community.
Thanks. Yeah, no, thank you. So one of the questions I had after watching your presentation, it's easy for me to understand how there's a number of missions that would absolutely be incentivized financially, right? To do the right thing, either from a regulatory standpoint or just from a raising capital standpoint. So my question is, what about missions whose primary incentive isn't exactly financial, right? So we have a bunch of missions maybe put on by Defense Department or other agencies who don't have a primarily financial incentive. So how would they fit into the system and model?
So one of the reasons like this research sort of started was trying to solve the problem of crowded orbits. To solve that, I figured out that I needed to tackle identity for spacecrafts, and that's what I'm presenting today. But ideally, with crowded orbits, you would you would associate a predictions market that estimates risks or estimates risk of satellite collisions, and you tie that predictions market to a bonding curve, which I show in the presentation as in this sort of use case and example. And that way you incentivize actors to behave properly in a, let's say the low orbit, for example. So it's less to do with, yes, this presentation talks about financing missions, but there are more use cases. The initial use case was about more like space sustainability, especially with regards to space traffic management. So with irrespective, I would assume with irrespective of who the actor is, whether they're defense or they are private or education or research, I would assume space traffic management was something that is kind of like important for everyone to be part of. So this is, I guess, a foundation. The presentation is really a foundation towards that sort of research, because I couldn't do that in a presentation without addressing this issue. So yeah, so I use this idea of financing one's mission, for example. While that is not necessarily the case, and I would not expect someone like Boeing or SpaceX or even like a defense contract, any kind of defense contractor or like nation state to do this. What this would help is for individuals, like say a hobbyist who wants to make their own CubeSat, a student club who wants to finance their own maybe subsystem design that's highly complicated, or even like small groups, so it just really for like small players who want to kind of finance their sort of their build. The method of doing it using something called a bonding curve, which creates something called an automated market maker, is sort of ideal because it develops this liquidity, which is very important, because one of the advantages of AMMs is that it provides liquidity for highly illiquid projects. And what that means is like projects that are hard to finance, like someone like a small student club may be hard to finance in some places on the planet. It's easier for them to finance their sort of small projects. So.
Okay, thank you. Another thing that I was curious about, and I feel this probably falls into the future work section of what you presented, but was how you mentioned in the presentation how this could be useful for for governance or for in some ways regulating the spacecraft. So I was wondering how that would fit in structurally, not necessarily which policies but where that would fit in the architecture structurally and how it would deal with all the various jurisdictional boundaries that we deal with when we operate in space.
Yeah, so currently the way that works is, so crypto economic systems is, or essentially, they're just frameworks to help manage digital economies. So governance is baked into them. So, I mean, to realistically put it, it's really an app, like a web application that you have access to the economic aspect as well as governing. So when people are actually doing governance, they would use that as their portal to doing any governance or any sort of voting. In the case of, like in this case, in terms of space traffic management, for example, you be looking at people involved in the governance, being involved in that process, and they would be doing it. I mean, you'd have different actors that would provide proposals to certain aspects of managing the low, for example, low Earth orbit, and people pretty much all, so all actors within that ecosystem would have a chance to vote on it, not just certain, people. So it's kind of like a it's a kind of a governing system for areas that are normally considered common pool resources. So pretty much everything above 100 kilometers is considered like above the common line is space. So you kind of have that area where there is no real jurisdiction. So you could classify it as a common pool resource, and therefore, like, how can you govern something like that? So realistically, it's really just a web app, or well, most of them are web apps at the moment, and you each representative, like you have, I mean, during the pandemic, you're seeing a lot of government officials on Zoom calls, so it's pretty much like that. You'd be on a Zoom call, and then you'd be voting live on a proposal or any kind of governance decision. And that would be recorded on the blockchain in real time. So, so that's kind of like the approach of governance, I guess.
Okay. Sounds good. Thank you. While we're talking, we got a question that came in from our audience, addressed to all panelists, although Red has already answered it in text message. But anyway, so question is your product limited to the use in CubeSat engineering, or can it also be used in larger satellites? And I don't know who would like to take that first.
So I can start off. So Sedaro satellite is targeted at kind of both markets. We think of it a different way for each segment. We kind of put traditional space in one box and small satellites in the other, including CubeSats. We think most of the volume in our market will be the small sat market, because these teams are more open to new tools and also more like reduced fidelity, but rapid and rapid engineering that doesn't require so much specialized siloed expertise. And so, we're looking to serve small sat teams in their full project lifecycle, but then there's also a lot of interest from the traditional folks because they don't have good tools for early stage conceptual design of their missions. So the reason that folks like NASA and Space Force are funding some of our development is because they want a tool for that rapid collaborative development in the early stage. They can evaluate multiple designs and then moving forward after that, connect that design information to other tools, their traditional tool sets, to carry out the detailed design and analysis.
Thanks. DeltaV?
Yes, actually, I agree with the answer of Robbie. The same thing for us. Major of our customer is small set and constellations, but yes, there is a demand in the traditional space. As he has rightly put, there are no certain tools which helps in the initial phase, and sometimes also the way they are using the technology is very outdated. If I can say that, because the new computing technologies or the new software technologies are not being used, they might be very slow even. So we do have certain scope for traditional space, but majority of our customers will be small sets.
Sounds good. Thank you.
Yeah, nice.
Okay.
I can add.
Yes, please.
Oh, sorry.
Please,
No, I was saying that the machine learning tool we have does not depend on anything from the input perspective. So you can have a large matrix with a lot of parameters that comes from a large spacecraft. That's all fine. The only thing you would need is a big processing unit behind, right? This is machine learning training. What we're thinking is actually doing multiple spacecraft analysis ourselves. So, and this is a bit complex, there's the question between small spacecraft and big spacecraft, but there's also the question between a lot of small spacecraft and a big spacecraft. So, and we're trying to propose something with the OPSAT mission from the European Space Agency to actually make a proof of concept of using the SatNOX network as a computing network. So we actually get the data on those ground stations and we actually compute there. So in a distributed way, we're trying to explore those things. Yeah.
Interesting, thank you. The next question is for Vikram. Do you expect international traffic law and who will enforce it?
It's international traffic law. So I'm not a legal expert, but the way I guess the idea is to make doing something like this. So a crypto economic system is essentially it's equivalent to a political economy. So what I mean by that is pretty much everything you do in life, like whether it's just exchanging, like paying someone, or you're living in a flat with other flatmates, and like you're deciding on what you're going to buy for the week, or to what kind of funding you need to do for your local community, or like a city or a government, goes on to things like you have consensus and you have a settlement. Settlement involves the economics aspect, and consensus involves the governance aspect, and those two are quite tied to each other quite well, closely. That's because we associate capital, which is to do with economics, to governance, which is consensus. So from what I expect with crypto economics systems using this way, governance and international law would come under the consensus aspect or the governance aspect, and that is tied closely to the economics aspect. So that whether those sort of international space traffic laws are set up or not, they would be somehow what this sort of framework or tool would enable would hopefully make it a lot easier and do it more in real time. So I guess I don't know if that answered the question properly, but yeah.
All right, thank you, appreciate it. Okay, so one more question just came in for DeltaV. You mentioned your digital twin can be used in a test bed. Is this product able to work with real-time data, and how does this work with the cloud?
Yeah, so as I explained it before, so we have a digital prototype which we can build in SatPass. So you have a digital twin. So now what we are allowing you use your telemetry data to pass into our digital prototype, which updates your digital prototype, and you can fetch which makes your digital twin. Currently, we are not giving it in a real time. You have to do it offline. In future, we are trying to make it a real time event.
All right, sounds good. Thank you. It looks like we are out of questions from the audience for now. So what we'll do is we'll have brief closing statements from all 4 of our panelists, and I'll give the audience maybe another 2 or 3 minutes to think of more questions. And if there's no more questions, we'll wrap up after that. So how about we start with Vikram?
I'd just like to say thank you for having a panel, and if you're interested in collaborating and helping out, so all this research is open source, so it will go on mostly on GitHub, thank you.
Thanks, Red.
Yes, microphone. Yes, so the same here. Thank you very much. This was nice to be here. we also have an open source project, so you can reach out to us. All the links and information are on our Polaris ML.space website. I invite you to join us in the channel. We have a channel where we chat every day, and we have people from Canada to India, so we will always answer your question wherever you are on the globe, almost. Yeah.
Sounds good. Thank you. DeltaV.
Thank you so much for providing the opportunity. It was really great. And also, if you want to use the software, just simply reach out to us because it is ready to be used. And we have provided a survey if you like to check how do you feel about the software and whether you would like to use it or not. So feel free to do that. Thank you.
Sounds good. Yes, thank you. Robbie.
Yeah, so would like to also, thank the CubeSat Developers Workshop, John and Ryan and Gown and everybody that put it together, and for this opportunity to share what we're working on. Like I said, our platform's going live in the next few months. For any updates on that, you can go to our website, Sedaro.com. I have contact information at the end of my slides. If you'd like to reach out directly to me, if you're interested in the tool or a demo. And yeah, we're really excited to see where things go with our project and the other ones in this group here, and excited for all the change that's happening, in how we build satellites and how we operate them.
Sounds good. Thank you. Good. One more question come in for Vikram, and then we'll wrap it up here. So, question is, how about landing rights? Can you predict who will get landing rights? We're going to have many communication small sats. Is what the question.
Sure. Did you say landing rights?
Landing rights, yes. The question is about landing rights. Is that envisioned as part of the infrastructure that you're creating?
Do you mean landing rights on the moon? Or?
My assumption would be either moon or Earth potentially.
Oh, okay. Yeah. So what the framework actually helps is to actually help stakeholders or actors in, say, for example, landing rights, help them decide a lot easier. So I think, yeah, Red mentioned it. So it's a form of decentralized governance. So that means when you have as I mentioned, like above the common line, everything is, you can legally argue is international by international law, and it's not purview on any nation state. And what that means is, like, pretty much you can get away with anything. And what this allows is the framework where people or actors participating in that ecosystem above 100 kilometers are also involved in the decision process and also the governance. So if it's to do with landing rights, for example, everyone who is involved in it would be able to vote on it, make a proposal, and then based on those proposals can either vote on it or not. Yeah, so that's kind of, it's just a tool to make things a lot easier and increase, I guess, make it more efficient from a economic as well as a governance standpoint.
I think we should have a serious game about that, with the stakeholders with the launch pad or stakeholders with the landing pad, and trying to see the economics. Cool.
The simulations of it, the complete simulations of that.
Exactly.
Indeed. Okay. So one more question, since we don't have to cut off the session right away to get to the next one, since we're the last one of the day. That gives us a little bit more flexibility. This is also for Vikram. Do you encounter any memo of understanding, MOUs, between governments?
And so encounter any what? Memo?
Or anticipate any memos of understanding, memorandums of understanding between governments?
Between government? Yeah. I'd say those questions are pretty far off into the future. Definitely. So I think the best way to answer this is to look at the way cryptocurrencies are viewed among governments at the moment, because it's very similar. And there are governments trying to put more regulations on it. which is a good thing. But in the end, it's really about, I'd say like, if there is any model of what you'd see like in the space industry, it would be very similar to what's happening in that space or that sector. So you'd see governments, you'd hope that governments are cooperating more with each other on things like this. Yeah.
Okay. Thank you. And then there's one just more sort of administrative question: how to contact the panelists. My suggestion there, obviously, replied in the chat. But my suggestion there is to look at the presentations, because the contact information should be included in the individual presentations. And if that doesn't, if that information is not in there, please just reach out to the workshop, and we'll try to put you in touch with each other. And with that, I'd like to thank everybody for being on the panel and taking the time today to discuss your work and the time to put the presentations together. I appreciate all of that in the discussion. So thank you very much. Ryan, back to you.
You're welcome. Thanks.
Thank you, John, for that. And thank you to our panelists. Those were all very, very great, great discussion and great talks that you guys had. So with that, that is our last live Q&A panel of the day. We do have the virtual exhibits open this afternoon, right after this, or starting about 10 minutes or so. So please, I would suggest go engaging with the exhibitors and sponsors there. We've got a lot of great exhibitors that have all kinds of services and products. And it's a great time to be able to engage with people in more one-on-one and personal format as well. Tomorrow, we again have a full slate for everyone. We'll have the exhibits open in the morning and the more side meetings from our sponsors in the morning as well as we have 2 keynotes tomorrow starting at 9 a.m. Pacific time. So please definitely engage with that. And then we have an additional panel later in the day starting at 2 p.m. Pacific time. That is from the Department of Education and their CubeSat mission CTE. And we'll have 5 high school panelists from that competition that they ran. So that'll be another very interesting talk tomorrow as well as the exhibits will still be open tomorrow afternoon. So thank you everyone for today, and hopefully we'll see you in the exhibits right after this. All right.
Bye. Thanks, everyone.
Thanks, everyone. Thanks.
Thank you. Bye.